Hi guys! Today we're going to learn about factoring expressions. It's going to be our last lesson, and then you guys are going to do your Chapter 7 test review on Wednesday with your Chapter 7 test to follow on Thursday. So when we start factoring linear expressions, we are going to go ahead and we're going to talk about different parts of those expressions. So first of all, a monomial is a number, a variable, or a product of a number and one or more variables. So a monomial could be something like 3x. It could be something like 7b. Doesn't matter which variable we use, but it can either be a number, so it could be something like 4. It could be a variable just like a, or it could be a variable and a number multiplied together, because that's what product means. An example of a non-monomial would be something where we have adding or subtracting. So if I had something like 3x plus 7, that is not a monomial. If we had something like 3x squared minus 10, that is not a monomial. So a monomial, we're dealing with things that have one term in them. I can't have more than one term. Okay, to blank a number means to write it as a product of its factors. So we're going to say to factor a number means to write it as a product of its factor. A monomial can be factored using the same method you'd use to factor a number. The greatest common factor, GCF, of two monomials is the greatest monomial that's the factor of both. So we're going to start out by finding GCF, which should be a review from 6th grade. So example 1, find the GCF of 4x and 12x. So what we're going to do is we're going to go ahead and we're going to put each term over by themselves. So we have 4x and we have 12x. Now remember, to factor something means that we're looking for all of the options of the two things that I can multiply together to get what's up there. So to get 4, I could do 1 times 4. I could do 2 times 2. If I check 3, 3 doesn't work because nothing times 3 gets me 4. And then we look at my variable and we have an x, so we can go ahead and bring our x down. Now we can go ahead and take a look at 12. Remember, when we're factoring, it's most important that we always start with 1, then check 2, 3, and go all the way up until we get to 12, so that way we make sure we don't forget any. So 12x, we have 1 and 12. We have 2 and 6. We have 3 and 4. Now, because 4 is in the right-hand column, we know that we can stop going back up because we've listed all the factors. And the 12x also has an x, so we can go ahead and we can bring that x down. Now what we're going to do is we are going to circle everything that the 4x and the 12x have in common for factors. So as we can see, they both share a 1, they both share a 2, and we're only going to circle one of those 2's, and they both share a 4, and they also both share an x. So in order to find my GCF, I am going to see what is the highest number that I circled. And if I take a look, the highest number I circled was 4, but then I also circled the variable, which is x. So that means 4x is the biggest thing that I could take out of both of those items. So my GCF is 4x. Now we can scroll down to the next one. We can take a look. It says, what is the GCF of 18a and 20ab? So I can go ahead and we can write 18a on this side. We can write 20ab on this side. And we can go ahead and we can start factoring. So if I have 18, we have 1 and 18. We can check 2 now. 2 and 9. 3 and 6. 4 doesn't work, 5 doesn't work, and then 6 is back in my right-hand column, so I'm all set. And I have a variable, which is a, so we have to put that in our list of factors too. Now I can go ahead and I can move on to 20. So 20, we have 1 and 20. We have 2 and 10. 3 doesn't work, 4 and 5. And if we can look, 5 is in the right-hand column, so we are all set. And then we have variables, we have A and we have B, so remember we're going to list those separately because they are different things. Okay, they're not the same letter. Now what we can go ahead and do is we can go ahead and circle all the things that are in common. So all of our common factors are the 1. We also have 2 in common. 3 we don't, 6 we don't, 9 or 18. So our numbers are all set, and then we need to circle the variables that are in common, so we have A's, so we can go ahead and circle those. And now, once again, I'm going to look for what is my highest number that is circled. So my GCF equals 2, and they both share an A, so my GCF is 2A. So once again, we're able to find the GCF of example 2. Now, we can try one more of GCF. So GCF, we have 12 CD and 36 CD. So we can go ahead and write 12 CD over here. We can write 36 CD on this side, and we can go ahead and we can start factoring. If you want to, take a moment and factor this by yourself, hit pause, and then when you think you have it all factored and found the GCF, go ahead and hit play again and check your answer with my answer. So we have 1 and 12, 2 and 6, 3 and 4, and then we have C, and then we have D. If I check 36, I have 1 and 36, I have 2 and 18, I have 3 and 12, 4 and 9, 5 doesn't work, then we have 6 and 6, and then I'm back up the right hand side so I'm all done, and then I have C and D. Now I can go ahead and I can circle all those terms that are like, so we have 1s, we have 2, we have 3, we have 4, we have 6, and once again we're only going to circle one of them, and we have 12, and then we can check our variables. We have the C's in common and we have the D's in common. So now when I go ahead and I write my GCF, I'm looking for what is my number that is the largest, and as you can see the largest number circled in both is in fact 12. So we can write GCF equals 12, but we have to check our variables, and we can see that we've circled both the C and the D, so our GCF is 12CD, okay, because they share those things. Remember, GCF is greatest common factor, so we're looking for the number that is the largest. So perfect. If we can factor, and we can do GCF by finding the factors, then we can go ahead and we can factor an expression. So it says you can use the distributive property to work backwards and the work backwards strategy to express a linear expression as a product of its factor. A linear expression is in simplest form when it is expressed as the product of its factors. So we can go ahead and we can fill in the line with the word simplest form. Now factoring is going to be something that you're going to have to be able to do when you guys go to 9th grade next year, or 9th grade math algebra. So in order to factor, all we're going to do is the same exact thing we were doing up in examples 1, 2, and 3. We're going to go ahead and find the GCF of everything. So what we're going to do is we're going to split 3x plus 3x plus 9 into two different terms. So as you can see, the first term we have is the 3x. The second term we have is the 9, and we're going to go ahead and we're going to factor everything here. So in order to factor the 3x, we go ahead and factor the numbers. So we have 1 and 3. There's no other factors, and then I have the x, so I can go ahead and write the x down. And now we are all set. For 9, we can go ahead and factor. We have 1 and 9, and 3 and 3, so we're all set. And then just like GCF, we're going to go ahead and we're going to circle things they have in common. So they share 1s, and they share 3s. Perfect. And once again, we're only going to circle one of the 3s because they only share 1, 3. Now what we're going to do, which is different than what we've seen before, is we are going to, with the distributive property, we write a number outside of parentheses, and then we write the parentheses, two things inside. So what we're going to do is we are going to find what is the largest thing the 3x and the 9 share. And if we take a look, it is the number 3. So what we're going to do is we're going to circle the pair of numbers that make up that factor. So we want the 3 and the 1 goes with it, so we circle that. And then here we want this 3, so we circle the other 3 that's with it. Now what we do is the thing that is largest and in common, we go ahead and we write that outside the parentheses. So because they both share 3, we write that outside. And now what we're going to do is whatever number is left over with that 3 in that purple circle, we're going to go ahead and we're going to write inside. Now because the 3x comes first here, whatever is left over needs to come first down here. So as you can see, the 1 is left over, so we're going to go ahead and write that 1 there. And then because we didn't use the variable, we have to make sure we put it back in, so we're going to leave it as 1x. Now our operation up here was plus, so our operation stays plus. And then same thing as our 9 comes second up in our original equation. So what we're going to do is we're going to find what's left over with the 3 that we pulled out in the green circle. And as you can see in the purple circle, that is a 3. So we're going to go ahead and we're going to write our 3 here. So our factored form is 3 in parentheses 1x plus 3. Now in order to check my answer, if I use the distributive property, I should end up getting 3x plus 9, which is what I started with. So if we take a look, we have 3 in parentheses 1x plus 3. If I use the distributive property, I give to this guy and I give to this guy. 3 times 1x is 3x. 3 times 9, or 3 times 3 is 9. So this guy indeed matches over here. So that means that we factored correctly. But this right here is going to be our final answer. Okay, this is factored form right here in the big green circle. So like I said, it's a little bit different, but we're going to go ahead and we'll see what we can do. So let's go ahead and try example 5. Example 5 is 12x. It says factor 12x plus 7y. So once again, we can go ahead and we can split these into two different terms. So we can split it into 12x and 7y, and we can go ahead and we can factor. So 12, we have 1 and 12, 2 and 6, 3 and 4, and we have the x. We're going to go ahead and bring that down. Our 7, we have 1 and 7. There's no more factors of 7, and then we have y. If we go ahead and we circle, we can see that the 1's are in common, and that's all they have. Now, if the 1 is all they have in common, this means that there is no factoring. There cannot factor. So what we go ahead, because 1 is the greatest thing, so it means that there's nothing we can pull out. It's just going to be the same thing. Because remember, anything times 1 in itself. So what we can write is we can write does, oops, I spelled that wrong. We can write does not factor. That is our answer. So sometimes if 1 is their greatest common factor, then the overall expression up here does not factor. So if we take a look at example 6, it says a garden has a total area of 15x plus 18 square feet. Find the possible dimensions of the garden. So we're starting with 15x plus 18. And if we want to find the dimensions, we want to factor out because we're looking for what times what gets me 15x plus 18. So I can go ahead and I can write my 15x on one side, and I can write my 18 on the other, and I can go ahead and I can start factoring. So 15, we have 1 and 15. 2 doesn't work. We have 3 and 5. And now we're back, 4 doesn't work, and then we're back over to 5, and then it has an x. If we take a look at the 18, we have 1 and 18. We have 2 and 9. We have 3 and 6, 4 doesn't work, 5 doesn't work, and then we're back with 6 on the right-hand side. So we can go ahead and we can circle the things that are like. So we have 1 and 1, 3 and 3. That looks like it's the biggest. So what we're going to do now is we are going to circle the pair that the largest number comes in. So once again, the largest number is 3, so we're going to circle the pair using the pink. And then what we're going to do is we're going to go over and we're going to actually use our parentheses again to write what our term's going to look like. So now the largest number that they share was the 3, so that goes on the outside. And then on the inside is going to be the 2 things left over. Because the 15x comes first, I'm looking for what was left over that I didn't use. So if we take a look at the 3, the thing that was paired with the 3 was a 5. So the leftover 5 is going inside, and we didn't use our variable x, so I have to make sure I leave it with it. And then our sign was addition, so we keep addition. And then we look for the 18. When we use the 3, the thing that was left over was the 6, was its pair. So then we go ahead and rewrite the 6 inside. So in factored form, we have 3 times 5x plus 6. Now, it's asking for the possible dimensions, so what that means is what times what is going to give me the area. Well, remember that when I have 2 things that are squished next to each other, like these 2 things, using parentheses, it means multiplication, so that could be the same thing as length times width. So we can go ahead and write a sentence and say that the possible dimensions are 3 by 5x plus 6. Now it doesn't matter that we don't know what x is because it's just a dimension we can always plug in for x. So once again, this right here is what factored form looks like when we're done with, okay? So that would be, along with your sentence, your final answer. Now you got yourself some practice problems, so if you still have time left in class, you can go ahead and you can work on your practice problems. You have 1, 2, 3, 4, 5, and 6. And I guess you have 7 too. If you finish those, you can feel free to work on the homework problems. Your homework tonight is going to be all of the problems, which is 1 through 10. Make sure when you're done taking all the notes and your notes just match my notes, that you go and show Mrs. Curry so that you can get credit for having your notes complete. I will see you all on Friday.